Hi students, today we are going to see the second chapter, numbers and sequence, right? Here, first we introduce the sequence. Let's see what is the definition for sequence. A real valued sequence is a function defined on the set of natural number and taking the real values. We know already have studied in the first chapter about the functions, right? The natural numbers are taking the real values. It is the natural number, it is a real number. Let me take as the natural number 1, 2, 3, 4, 5 like this. In mapping the real numbers, whatever be the real number, let me take this A1, first term, A2, A3, and then A4, and then A5. So, the natural numbers taking the real values, that is called the sequence. The sequence are arranged in some specific order. See, the sequence can be written in the form of A1, A2, A3, A4 like this up to AN term. For example, if you take the number 1, 3, 5, or take as 1, 4, 9, 16, 25, 36. This arrangement of some specific order, this is the arrangement of some specific order is called a sequence. All the arrangement of elements are called a sequence. Here I have some specific orders. Let's see, here it has the A term, AN term. Let me take this AN. This term is in square format, n square form. Here we have n square form. If you put n is equal to 1, 2, 3 natural numbers, right? We put n is equal to the natural number, we get this value. So this specific order is called a sequence. So, and then we have taken another sequence 1, 3, 8, 15, 24, 35. It goes on like this. This is also a sequence. So this nth term of the sequence is, we mentioned as an is equal to, here see, nth term is n square minus 1. So n square minus 1, let me take the first term as 0, right? Here n is equal to 1, 2, 3 up to the natural number. If you put n is equal to 1 square minus 1 is 0. And then 2 square is 4 minus 1 is 3. So in this specific order we arrange the elements are called the sequence. And then the first term is always called here the 1 is called the first term of the sequence, and then the second position is called the second term of the sequence. The third position is called the third term of the sequence up to the nth term. So the first term, first place position, and then second term it is in the second place position. So the first term is here for this term. Here the first term is A1, right? And then up to the nth term, here the nth term is AN, right? The position is mentioned in the terms. Position of first position is the first term, second position of the element is the second term, and then it goes on up to nth term. Now we continue this with the arithmetic progressions. Let's see the arithmetic progression. We call it as AP. Then here, all the sequence are not a AP, but one condition: if that particular sequence have the common difference. If the sequence have the common difference means we can say it is a AP sequence, right? Then here, see the definition. Let A and D be the real numbers. Let A and D be the real numbers. Then the number of the form A plus D, A plus 2D, A plus 3D is in the general form of the AP term. General form of the AP term, A plus D, A plus 2D, A plus 3D up to it goes on nth term, right? Is said to be an arithmetic progression. The number A is called the first term and the D is called the common difference. So I already told you that the sequence are not a AP, but if the common difference are equal, then we can say it is a AP. Suppose I take that CPS, first we have taken as 1, 4, 9, 16, right? How to find the common difference here? We have the common difference formula. Common difference is denoted by the small d. Second term minus of first term. Second term, that is t2 minus t1. Here t is mentioned the terms, right? T is mentioned the terms. So d is equal to second term minus first term. For this sequence, I take as second term d is equal to, here this is t1, t2, t3, t4. See the second term minus first term, t2 minus t1 is equal to, we have 4 minus 1 is equal to 3. And then third term, d is equal to t3 minus t2. The third term is 9 minus 4 is equal to, we get 5. See, here the common difference are not equal. First of all, I said this is a sequence, right? But in the sequence are not here AP. Right? Next we take the odd numbers 1, 3, 5, 7, it goes on. Right? Now we have to check the first question is the first term, second question is the second term. So let me take this T1, T2, T3 and then T4. Here we are going to find the common difference. If the common difference are equal in this term, we can say this sequence is a arithmetic progressions, right? Here common difference is denoted the small d, d is equal to second term minus first term is equal to, here second term is 3 minus 1 equal to 2 and then t3 minus t2 is equal to third term minus second term, third term is 5 minus 3 is equal to, we get 2. See here we have the common differences are equal, right? Common differences are equal. Then we can say this sequence is a arithmetic progressions, right? Here we have the general term and general form. Here it is the general form of the AP. We say it is a plus d, a plus 2d and it goes on. It is a general form. Here the first term, the first quotient A is called always the first term of AP. A plus D is the second term of AP. So in the nth term we have Tn is equal to, nth term, general term of AP, we have the formula Tn is equal to A plus n minus 1 into D. See, here we have one number is less than that number, right? So it is in the order of first term is A, and then second term is A plus D, and the third term is A plus 2D. If I apply the value of 1, we are going to find the first term. First term is T1. In the place of N, I put the value 1 means we get A plus 0 into D is 0. So the first term is always A. Right? And then T is equal to the second term, A plus, in the place of N, we are going to apply the value, N is equal to 2 minus 1 is 1. 1 into D is nothing but A plus D. So it is the form of the first term is A, second term is A plus B. So the nth term of general term or nth term of AP is Tn is equal to A plus n minus 1 into D. So the first term is always mentioned in the form A and the common difference is D. Next we see the three consecutive terms. And here we want to find out the nth term. Nth term means for this formula, when the last term is number is given, for the sequence that is 1, 3, 5, 7, then 19, the last term is given means, here we want to find out how many terms are there. How many terms of the AP. Here we have the formula n is equal to L minus A divided by D plus 1. Here we want to find how many terms. We cannot be able to count the larger number, larger sequences given means we cannot be able to count. By using this formula n is equal to L minus A divided by D plus 1, we can be able to find how many terms are in the AP, right? Next, the three consecutive terms of AP. Consecutive means next numbers, right? The three consecutive terms are A minus D, A and then A plus D. Here we have the common difference as D. The three consecutive term having the common difference as D is the common difference. So consecutive means next sequence. That is the next terms is called the right consecutive terms, right? Next we have 4 consecutive terms. Next we have the 4 consecutive terms. We have the common difference is 2D. Common difference is 2D. So here we have a minus 3D, a minus d, a plus d, and then a plus 3d is the 4 consecutive terms of the AB. By using this form, we can apply to the problems to solve this one. Next we see the series. Series is nothing but the addition of the sequence, right? See the series, the sum of the terms, the sum of the terms of the sequence is called a series. The sum of the terms of the sequence is called a series. Here we have the general term of the sequence is A1, A2, A3 up to AN terms. Here the real numbers are the addition of the sequence is called a series, right? A1 plus A2 plus A3 up to the AN term is called nothing but it is a series. Addition of the sequence is called a series. Now we see the sum of n terms of an AP, right? Sum of n terms of an AP here. First we take the general form of the AP. So we know the general form of the AP, that is A plus D, A plus 2D, then A plus 3D, it goes on, right? Now we have to add the given form. In the AP form, we want to add the sum to n terms of an AP. This is nothing but a series, sum of the AP, right? So sum of the AP means we have to add each and every term. By here, we using the symbol SN for addition of or sum of the AP, right? Nth term is equal to, here we have A plus, the second term is A plus D plus A plus 2D, and then it goes on A plus n minus 1 into D. So up to the nth term, right? So addition of the nth term of AP. So we mentioned it as a sum of means that is Sn, right? And then here we have two formula to find out the sum of the AP terms. Here Sn is equal to n divided by 2 into 2A plus n minus 1 into D. When we know the first term and the common difference is known. When common difference D is known means we use this formula, that is sum of Sn, that is Sn means sum of the nth term n divided by 2 into 2A plus n minus 1 into D, and then where Sn is equal to n divided by 2 into A plus n. When we know the last term, for example, here the sequence is 1 plus 3 plus 5 plus 7, it goes on like this, right? Here we don't know what is the last number, but we can be able to find the common difference from this sequence, right? From this sequence we can be able to find the common difference. So here we using the formula of n divided by 2 into 2A plus n minus 1 into. Suppose in case here we have 99, that is the last number of the sequence. Here the L is known. When last term of the sequence is known, when we use the formula Sn is equal to n divided by 2 into A plus L, right? When last term L is known. Let's go through the sums. Right? Hi students, today we are going to see the exercise number 2.5, question number 1. Check whether the following sequence are in AP. First of all, we want to say that the sequence is an AP sequence or not AP sequence means first we want to find out the common difference. If the common difference are equal means then the sequence is an AP, arithmetic progression. Otherwise, it is not a arithmetic progression. Let's see the first Roman number is given as A minus D is the first term, A minus 5 is the second term, A minus 7, that is A minus 3, A minus 5, A minus 7. Let me take this T1, T2 and then T3. Term 1, term 2, term 3. First term, second term, third term, whatever, right? Then we want to find out the common difference. Common difference we mentioned as small d is equal to second term minus first term. And also we want to find out the third term minus second term. If the two common differences are equal, then it is an AP. Next we have second term is a minus 5. Here we have formula minus of the first term, that is a minus 3. Now here we have to careful when we are writing the second term. Even there is no negative value also, you put the bracket. That is very easy to find out the correct difference, right? Common difference. Then a minus 5. Here we have minus a, minus into minus plus 3. Removing the bracket, right? Here we have plus a minus a cancel. Minus 5 plus 3 is equal to minus 2. Then the common difference of third and the second term, T3 minus T2. See, the third term is a minus 7 and it goes on it. A minus 7 minus of the second term. When you are writing the second term, just use the bracket. It will be avoid some mistakes, right? Then first term minus into plus minus a minus into minus plus 5. Plus a minus a both are cancelled. Minus 7 plus 5 is equal to minus 2. Therefore, here the common difference are equal, right? Let me take this d1, d2, right? The common difference d1 is equal to d2. Therefore, the given sequence is an AP sequence, arithmetic progression. Next we see the second Roman number. See, the second Roman number is given as 1 by 2, 1 by 3, 1 by 4 and 1 by 5 is given. First we want to find out the common difference for this term. Let me take it as the second Roman number. See, the second Roman number is given as 1 by 2, 1 by 3, 1 by 4, 1 by 5 and it goes on, right? So, first term we take as T1, second term T2, third term T3 and then fourth term T4 it goes on. Here the common difference d is equal to second term minus first term is the formula. That is generally related is the d is equal to tn minus 1 formula, right? That is second term minus first term. Here the second term is 1 by 3, T2 minus T1 is 1 by 2. Here we want to take LCM, the denominator is not equal. If you want to take the LCM means just multiply these two terms. 3 2s are 6, then cross multiplication 2 1s are 2 minus 3 1s are 3, then 2 minus 3 is equal to minus 1 divided by 6, and then let me take this d1. Next d2, common difference of second terms, that is t3 minus t2 or you may take as t4 minus 3t, right? Next time we have to take, here I take this t3 minus t2. The third term is 1 by 4 minus second term is 1 by 3. Now the denominators are not equal, so we have to take LCM for this term. If you take LCM, just multiply the denominator. 4 3s are 12 and then cross multiplication 3 1s are 3 minus 4 1s are 4. Next, this term is equal to 3 minus 4 is equal to minus 1 divided by 12. This is d2. See, here d1 we have minus 1 by 6, d2 we have minus 1 by 12. So d1 is not equal to d2. The common differences are not equal. Therefore, the given sequence is not an AP. Right? If the common differences are not equal, so we can say it is a not AP. Next we see the second question, the same exercise, right? First term A and the common difference D are given below. Find the corresponding AP. We want to find the AP sequence of the given terms. The first term A is given and then common difference D is given. We want to find out the corresponding AP. I am taking the first Roman number. For first Roman number, the value, the first term is A is equal to 5, and then common difference is given as 6. We want to form here AP means here we have the general form of AP. AP is, we know the first term A, second term is A plus D, third term A plus 2D, and it goes on up to nth term. So here in the place of A and D, you just apply the values of given first term and the common difference. You can form here AB, right? Let in the term first term is A. What is the value of A? That is 5. And then A plus D, right? 5 plus D is 6. And then A is 5 and then D is 2 times of 6. And it goes on. It is enough to find out 3 or 4 terms, that is enough. Therefore 5 plus 6 is 11. Here 5 plus 2 6 are 12, 12 plus 5 is 17. This is the corresponding AP of the sequence when A is equal to 5. The first term is equal to 5 and then common difference is equal to 6. Now we have to cross check it. Is it a common difference are equal or not equal? See the second term minus first term. 11 minus 5 is 6. And then third term minus second term. 17 minus 11 is also 6. So the common differences are equal, then clearly it is a AP sequence. The AP is 5, 11, 17 and it goes on, right? Next we see the second Roman number. Here A is equal to 7 and then D is equal to minus 5 is given. Let's take the A is equal to 7 and D is equal to minus 5. Now the same, we are applying the value of A is equal to 7 and then 7 plus of minus 5. Plus into minus 5, right? Directly I am going to write it here. Otherwise you just write in the next step. And then A value is 7 plus 2 into the value of D is minus 5. And it goes on. Next 7, here 7 plus into minus is minus 7 minus 5 we get value 2. And then here we have 7 plus into minus is minus 2 5s are 10. 7 minus 10 is equal to minus 3 and it goes on the term AP. Now we have to cross check that if AP is satisfied or not. See second term is 2 minus 7. 2 minus 7 is equal to minus 5. Right? Here third term is minus 3. The second term is 2. But in formula we have third term minus second term. So minus 2 is equal to minus 5. So here the common differences are equal. So it is a AP. Therefore the AP is 7, 2, minus 3 and it goes on. Student, exercise number 2.5, question number 4. Find the 19th term of an AP. The sequence is given as, AP sequence is given as minus 11, minus 15, minus 19 and it goes on, right? Now we want to find out the 19th term. We have the formula to find out the terms, that is general term of AP is equal to Tn is equal to A plus n minus 1 into D is the formula. So here 19th term means n is equal to 19 is given. So we want to find out first term and then common difference. So the given sequence is minus 11, minus 15. The given sequence is minus 11, minus 15, minus 19, it goes on. From here we want to find out the A term means always the first term is A. The given sequence, the first term is A. So A is equal to minus 11. Next we want to find out the common difference. For common difference, D is equal to second term minus first term, T2 minus T1. See here, second term is minus 15, the first term is minus 11. So second term is minus 15. In formula we have minus of the first term is minus 11. Then we have to remove the bracket here. So minus 15, minus into minus, plus 11. Then you subtract this, you get d is equal to minus 4. So, a is equal to minus 11 and then common difference d is equal to minus 4. Now we have to find out the 19th term of AP. So, T19 is equal to 19th term of AP is equal to, what is the formula? A plus n minus 1 into d. In the place of a is minus 11 plus 19 minus 1, that is n minus 1, and then common difference d is equal to minus 4. Next, minus 11, 19 minus 1 is 18 into minus 4. Then we have minus 11 plus into minus minus. Plus into minus is minus. 4 8s are 32, 2 remainder 3. 4 1s are 4 plus 3 is 72. So both having the negative symbol. So put the negative symbol and add the two terms, we get 83. So the 19th term of AP is minus 83 is the 19th term of AP. Hi students, exercise number 2.5, question number 9. Find x, y and z given that the numbers x, 10, y and 24 z are in AP. So the condition is the arrangement of this sequence is an AP means then the common difference are equal. That is the condition, right? So let me take the given sequence solution. That is x, 10, y, 24 and then z. That is the given sequence are in AP. That is the condition. The condition is given as AP. Then only we can find out the common difference, otherwise it is not able to find out the common difference. Now, first we want to find out the common difference. First I take D1. Right? Common difference T2 minus T1. Let me take this. The first term is T1, second term T2, third term T3, and then T4, and then T5. Then we are going to find out the common difference up to T5 minus T4, right? Then D is equal to T2 minus T1. The second term is 10 minus x. Let me take this equation number 1. D is equal to 10 minus x is the first term, and then D is equal to T3 minus T2. See, third term minus second term is equal to D is equal to, the third term is y minus the second term is 10. Let me take as equation number 2. Then D is equal to T4 minus T3. Fourth term minus third term. Here D is equal to, the fourth term is 24 minus the third term is y. I take the equation number 3 and then D is equal to T5 minus T4. D is equal to T5 is given as z minus T4 is given as 24. I take equation number 4. By using this equation number 1, 2, 3, 4, see the common difference are equal by the condition the sequence is an AP. The sequence is an AP. So this differences are, we have assumed we have taken this, the differences are equal. So here I am going to take the second and third equation to find the value of y. From equation number 2 and 3, here we have both having the y variables. So it is very easy to find out the y. Right? So the common differences are equal means y minus 10 is equal to 24 minus y. Because it is a AP by condition. So both the differences are equal. So I take the constant term to one side and then variable term to other side. Y plus y. Minus y turns to plus y, and here we have 24. It is minus. If you take other side, you get plus. Then y plus y is 2y. Is equal to 34. Then y is equal to 34 divided by 2. It is multiplication. If you take other side, it will be divided. Then y is equal to 17. So one of the variable y is find out that. Next we want to find out the x and the z, right? By applying the y value, y is equal to 17. Next we take as the term first and second, or second and the fourth, or third and fourth, like this. Next we have to take the first and the second equation to find the value of x. See, from equation number 1 and 2, the common difference 10 minus x is equal to y minus 10. Here we know the y value. Y is equal to 17. We have 500. So 10 minus x is equal to 17 minus 10. 17 minus 10 is nothing but 7. Next, I take this x to another side. 7 to this side. 10 minus 7 is equal to minus x down to plus x. Right? Then 10 minus 7 is 3. Therefore, x is equal to 3. Now we can choose any one of the terms. Either we can choose the third and fourth or first and fourth, whatever it be. Here I take the second and the fourth itself, right? Y minus 10 and then z minus 24. We take the second and the fourth equation from equation number 2 and 4. See, the second equation is y minus 10 is equal to z minus 24. And then you know the y value, y is equal to 17 minus 10 is equal to z minus 24. Then 17 minus 10 is 7, z minus 24. I take this 24 to this side. 7 plus 24 is equal to z. 24 plus 7 is equal to 31. Therefore, z is equal to 31. Here, the value of x, y, z are 3, 17, 31. Hi students, exercise number 2.5, question number 11. The sum of three constituent terms that are in AP is 27 and their product is 288. Find the three terms. First, the sum of three constituent terms is a minus d, a plus d is the three constituent term. By using this three constituent term, we have to find out the three terms, right? Solution. The three constituent term is a minus d, a plus d. These are the three constituent terms of AP. Now our question is the sum of three constituent terms. So we have to add these three terms. Then the AP is 27. So the first condition is sum of AP, that is a minus d plus a plus d is equal to 27 by the first condition. The sum of three constituent terms of AP is 27. So here adding the three terms is equal to 27. Now plus d minus d is cancelled, right? Here a plus a is nothing but 3a is equal to 27. Then we want to find out the a value. A is equal to 27 divided by 3. Then a is equal to 9. Now come to the second condition. Their product is 288. Their product means you have to multiply this term. We get 288. So the product is a minus d into a plus d is equal to 288. Now when we multiply this, here we have a minus d and then a plus d. It is in the form of a plus b and a minus b formula. So we can write it in the term a square minus b square into a is equal to 288. Here we know the a value, right? So now apply the a value. Here we have 9 square minus d into 9 is equal to 288. Now I take this 9 to other side. Here we have d square, right? So in application, so 9 square minus d square is equal to 288 divided by 9. If you divide by 9, we get 9 ones are 9 3s are 27, right? Remainder 1, 18, 9 2s are, that is 32. So 9 square is 81 minus d square is equal to 32. Now we want to find the value of d. So I take this d square to another side and 32 this side. 81 minus 32 is equal to d square. Then 81 minus 32 is equal to 49. Therefore d square is equal to 49. Then d is equal to plus or minus 7. Here we have the both the plus value and the minus value. Now we want to find that a minus d, a plus d. We have to find the three terms of the constituent terms, right? Here, then d is equal to 7. Here we have both plus value and the minus value, right? D is equal to 7 or d is equal to minus 7. First I take that d is equal to 7 and a is equal to 9. Now apply the a and d value in this three constant term, that is a minus d, a plus d. A is 9 minus d value is 7 and then a is 9, here 9 plus 7. So we get the value 2, 9 and then 16. One of the AP form, and then when d is equal to minus 7, a is equal to 9. See, first we have find out that 2, 9, 16 means if you apply the negative value, it will be automatically reverse order will be get. That is a minus d, a plus d means in the place of a is 9, in formula we have minus, and then d value is minus 7. Comma, a is 9 and then a is 9 plus of minus 7. D is equal to plus of minus 7. Then 9 minus into minus is plus 9 plus 7, comma, here we have 9 and then 9 plus into minus is minus 7. Then we get the value 9 plus 7 is 16, here 9 and then 2, right? So when we apply the positive value and negative value, the AP sequence is being the reverse order, that is the term. So this is the three constituent terms of AP.